We will be doing two questions of height and distance where question is already posted into the group. Okay. So what is that? Let us quickly come to the question. Okay. An aeroplane is given to you. An aeroplane is given to you. This is an aeroplane, right? And the aeroplane is flying and changing its elevation. Aeroplane is flying and changing its elevation. So the data as given into the question is that the angle of the elevation of an aeroplane from a point on the ground is 45 degree. After a flight of 15 seconds, the elevation changes to 30 degree, right? So the aeroplane is there and the elevation of the aeroplane from a point on the ground. Okay, let's say this is a point on the ground and this will be the angle of this will be the elevation and this will be the angle of elevation. Okay, and here it's the aeroplane. The aeroplane is flying here. Okay, and let's say this is the point A where the aeroplane is flying, right? And the angle of elevation of this point from, let's say, this point P is given as 30 degree, right? 30 degree. Now if the aeroplane is flying from a point on the ground is the angle of elevation of the aeroplane from point on the ground is 45 degree. After a flight of 15 seconds, the elevation changes to 30 degree. So basically this data as given over here is 45. This is 45 degree, and after a flight of 15 seconds, that means when 15 seconds of time, let's say this aeroplane reaches over here. Okay, the aeroplane reaches over here. Okay, and let's say this is the point B, then the angle of elevation is also changes because we are standing at the same point. So from here the angle of elevation will be this one, and this is definitely less than 45. So this is given to you as 30 degree, right? So the two conditions are given to you. The aeroplane is flying. Initial the condition was that it was on a position of A after a flight of 15 seconds of time. So this is the 15 second and time taken to reach. So in 15 second of time, aeroplane changes its position from A to B, right? This is the position of aeroplane which changes. Position of aeroplane as changes, right? From A to B in 15 seconds of time. Initial the angle of elevation from this point P was 45 degree, and after the 15 seconds of time, this time of 15 seconds, that is from here to here, if you are checking on the ground from here to here or here to here, it's a parallel line, right? You can see A to B, and let's say this is C to D. Now we need to find the speed of the aeroplane, right? It's also given that the aeroplane is flying at a height of 3000 meter. So the BD will be 3000, right? 3000 meter, and definitely that AC is also equal to AC is equal to BD is equal to 3000 meter, because this is the height of the aeroplane, right? Hi NBM Gummy, hello. So this is the given data. We need to find the speed of aeroplane. Aeroplane is what? So we just apply the concepts over here. Thank you for getting it, NBM Gummy. So we will take two conditions over here. What? In triangle ACP, you can see this is a vertical line, so this will be 90 and this will be 90, right? So we'll take two triangles. Triangle ACP, this one. So in triangle ACP, what will be the relation? You can see tan 45 is AC by PC. We can write tan of 45 degree equal to AC, and you know AC is 3000, so we can write 3000 divided by PC, this length, this one, by PC. So from here we know that tan 45 is 1, so 1 into PC, because this PC will be multiplied, this will be coming as 3000 meter. So the length of PC is calculated as 3000 meter, right? Now, the second part, come to the triangle PBD, right? PBD in triangle, you written ACP, so write in the similar fashion BDP. So in triangle BDP, right angle at D, tan of 30 degree, because this is the angle of elevation from the for the second position of aeroplane, right? So tan of 30 degree is given to you as BD by, the height of BD is 3000 meter already given. BD divided by PC plus CD. PC plus CD, or you can directly write PD, right? PD, right? Now, this will give you, just put up the value of tan 30 degree is 1 by root 3 is equal to BD. BD is 3000. You can see over here 3000 divided by PD. So this will give you the value of PD as 3000 root 3 meter, right? The value of PD is calculated over here. This distance P to D, that means when the from the point of monitoring to the final position of the aeroplane on the ground, this is PD, and this length is calculated as this much. Now we need to find the speed. So for the speed of aeroplane, we are calculating it, let's say in meter per second, the total distance, that means distance covered by time taken. What's that, right? The distance covered is this PD minus C minus PC, right? So this will be coming as 3000 root 3 minus PC. PC is 3000 minus 3000, right? This will give you the total distance, because from this triangle BDP, here from this relation we have calculated the length of PD. Okay, this length of PD here you can see. So the distance covered is actually PD minus PC. PD minus PC, you can see PD minus PC. So this will give you PD minus PC as 3000 root 3, as we have calculated, minus PC, this value 3000. So this is the total distance, and the total time taken is 15 seconds, right? So when you just calculate this value, this will be coming as 3000 into root 3 minus 1. Root 3 is 1.732. 1.732 minus 1 is 0.732 divided by 15, right? Divided by 15. So this will give you 15, 2 times 30, 200. So 0.732 into 200 meter per second is the speed of the aeroplane, right? This is the speed of the aeroplane, 0.732 into 200, which will be coming as 224, 236, 2714, 1464, and 20, then I'm applying the decimal. 146.4 meter per second is the speed of the aeroplane, which is calculated over here. The two conditions, as per the question, it was given that the angle of elevation of this aeroplane was changing from 45 degree to 30 degree in 15 seconds of time, right? So in this way we have solved it, right? Now quickly coming to the next question. The next question is that a window of a house is h meter above the ground. Okay, let's say this is a house. Let's say this is a house. Let's say this is a house, right? And from this house, the angle of the angle from this house, there is a window. So let's say this is the house 1. This is house 1, and there is a window situated let's say something over here. Okay, so this is the position of window. Okay, this is the window, and from here this house is situated on one side of a lane. This is a lane. Okay, let's say this is a lane, and the another side there is another house is situated. Let's say this is the height of the house. Okay, and this is the top of the house, let's say A, and this is the bottom of the house at ground B. And from the window, from one of the house which is situated on the another side of the lane, that is house 1, and let's say this is house 2. Okay, from here the window which is situated from at in house 1, the angle of elevation of the top and angle of depression of the bottom of the second house on the opposite lane. Okay, so this will be the angle of elevation and this will be the angle of depression, right? This will be the angle of depression and this will be the angle of, this is elevation and this is depression, right? So these two data is given to you. We need to find the height of the second house. This is how much, right? Now it's also given that the height of this window, height of this window of the first house is h meter above the ground. This is h. This data is given to you. So let's say if this is P, this is Q, right? And let's say this is a point O which is parallel to the QB, right? Then we can see we need to find the height. So if this P to Q is h, then O to B, what is the length of O to B? It's also h, right? This is also h. Now this is h, this is h. Now what we will do, if this is the angle of depression and the angle of depression is given to you as elevation is alpha and depression is given as beta, right? This is given to you. If this is the depression, then and then we can say PO is parallel to QB, then this angle is also equal to beta, right? Because alternate angles B, B, beta, beta. PO is parallel to QB and PB is the transversal. You can see. That's why this angle beta is equal to this angle beta, right? So now what we will do, we will take two triangles PQB, and from here we will find the width of the lane, this one QB, and similarly we take this second triangle and here we find the width of the lane and just compare it. Okay, then we'll get the value which will finally add up to give you the height of AB, right? We need to find the house to height, as h times 1 plus tan alpha cot beta, that we need to prove. This we need to prove, right? So here just take this triangle PQB. So in triangle PQB you can see it's a right angle triangle. Yeah, this is 90 degree, because from any point if you are drawing a vertical line to the ground, it's making a 90 degree, right? So in triangle PQB, this PQ by QB PQ by QB is the ratio of tangent. So this is equal to tan beta, right? And the length of PQ is known to you, that is equal to PQ is H. So this will be equal to H by QB, right? Finally, this gives you the value of QB as H by tan beta. QB as H by tan beta. This is the relation which you find, that is the width of the lane, right? Similarly, you can come to triangle POA. So in triangle POA, the upper triangle, this one, what will happen? Tan of alpha is AO by PO. AO by PO is the relation for tan alpha, right? From here, the width of the lane, that is QB, is equal to PO. So from this triangle relation, PO is the width of the lane. So we can write PO as AO by tan alpha, AO by tan alpha, but PO equal to QB. Since PO equal to QB, this is the lane width. So it will be same across. So this PO is equal to this QB, right? These both are equal. So since PO equal to QB, this gives you AO by tan alpha, that is the value of PO which we have derived, is equal to QB. QB is H by tan beta. So finally this will give you the length of AO as H times tan alpha by tan beta, right? This will give you the length of AO, right? Now what will be the height of house 2? So from here we can see that we need to prove H times 1 plus tan alpha cot beta. Okay, so height of house 2, we are almost arrived at our answer. Okay, height of house 2 is calculated as AO plus BO, isn't it? This is AO and this is BO, that both of these need to be added to calculate the height of A to B, right? So the height of house 2 is basically AB, which is AO plus BO, and the length of AO is calculated, and length of BO is also known to you, that is H, right? So just put up the value over AO is equal to H times tan alpha by tan beta. This is the value of AO I am putting over here, plus BO. What is the value of BO? BO is H. Okay, so we can write, taking H common, tan alpha by tan beta. So it can be written as tan alpha into 1 by tan beta plus 1, right? This will give you H times tan alpha 1 by tan beta is cot beta. So just take first one in as the first term, then we can write H times 1 plus tan alpha into 1 by tan beta is cot beta into cot beta. So H times 1 plus tan alpha into cot beta, you can see H times 1 plus tan alpha into cot beta. So this is the height of house 2. Height of house 2 H times 1 plus tan alpha cot beta, this is calculated. Okay, so in this way we have just solved the second question of height and distance, and we have proved the height of house 2. Okay, thank you so much for watching. Thank you.